Okay, and now I've got my classroom back, we can finish off this video. So the next one was all about Kruskal's algorithm and Prim's algorithm. Now this was, again, it was done mixed, and the, no one picked up any marks for part D, but questions A, B, and C we should have been able to do. So let's see how we do this one. We've got to use Kruskal's algorithm for the first one. By the way, I just watched some of the video back, and I'm sorry that my voice keeps going up and down, up and down. There's not an awful lot I can do about that. Okay, so Kruskal's algorithm. What he says is that you start off by choosing the smallest of all the arcs. So the smallest arc here is 6. So I'd always do a little diagram as well, just to help me out. So BC is 6 is the first one that we're going to select. And then the next one after that is AB. AB is 7 is the next one. That's A, B, C. So AB is the next one. The next shortest is AC. Now we have to say, sorry, AB is 7. We have to say AC and then ignore. We have to say that we ignore it or that we don't choose it. We don't need to say why, and it's because we select, because it would make a loop. So we say that we choose we look at AC, we consider it, but we do not choose it. And the next shortest one is DE, which is 10. See, they don't need to connect for Kruskal's algorithm. So DE is the next one that we choose. That's 10. The next one we choose is CD, which is 11. So CD, which is 11. The next shortest one is 13. So that's DF. Now the next shortest one after DF, which is 13, well, we've got a choice of two. We can either go for BF, which is 14, but that would make a loop. So we say BF, ignore. And we've also got to ignore CE down there. So CE, ignore. Okay, so once we've ignored those ones, the next one after 14 is 15, which is EJ. So EJ, which gives us 15. After EJ, we've got 16, which is FH. And we haven't connected all of them yet. The next one after 16 is this one here, 17, but that would make a loop. So we say HJ, but then ignore. Again, the people that don't write ignore or don't consider those ones only get a maximum of 1 mark on this question. It's quite a big question to lose everything on. After 17 was 19 over here, BD, but that makes a loop, so we say BD, ignore. After 19 is 20, which is GH. Then GH, 20. And then we can stop. And that is Kruskal's algorithm. So if we go back to the question, in each case state whether you're adding the arc to your minimum spanning tree. So the fact that it says state whether you are adding the arc to minimum spanning tree says that you must consider all of them in order and then say either choose or ignore. Okay, once we've done that one, starting at G, use Prim's algorithm to find a minimum spanning tree. You must clearly state the order in which you select the arcs from your tree. So we're starting at A. No, sorry, where were we starting? Starting at G. So we're going to start at G. And so the first one we do is GH. So GH. Of course, you can do your diagram, or you could just draw on your diagram and say GH is the first one we're going to choose. And the shortest one that's connected to either G or H is FH. So that's going to be the next one. The next one that's connected to that is DF, which is 13. The next one is DE, which is 10. The next one after this is CD. And after CD is BC. And next one is BA, or AB. Notice that these ones you don't need to say ignore anything. And then the only one that's not connected now is J, so it's going to be EJ for the last one. And that's all you need to do for Prim's algorithm. It's not that hard at all, as long as you choose the ones in order, but as long as they're connected to the existing one. So we started off with G, and then it's got to be connected to G. Once we've done that, it's the next smallest weight, which is connected to either G or H, which was that one there. And now it's the next smallest one, which is connected to either G, H, or F. So with Prim's algorithm, the main thing is it's got to be connected to our starting point. And once you've done that, you've got to then work out what the weight of the total spanning tree is. So we add together 7 plus 6 plus 11 plus 13 plus 10 plus 15 plus 16 plus 20. And if you do that, you should get 98 kilometers. And there are people that got that mark, which is good. But then the part which threw everyone is the final part of this question. I'm not surprised, it's worded quite nastily, I think. And it's up here. So a connected graph V has n nodes. So my advice for this is just to do a real simple diagram. So we've got a connected graph, which means that everything's connected. And it's got n nodes. So the sum of degree is m. So that means that the degree for this one is 1, and the degree for this one is 1. So the total, the sum of the degrees in this case, equals 2. The graph T is a minimum spanning tree of V. Write down in terms of m the number of arcs in V. So here, when the sum is 2, the number of arcs is going to be 1. If we were to add another one, then that would be 1. This one, the degree would then be 2. So the sum would be 4, and there's 2 arcs. Now the reason being is that every time you add in another arc, it's going to connect 2 nodes. So it's going to go into this node here, and this node here. So each time, each extra arc is going to give you an extra 2 to the total of the degree. So if the degree is m, then the number of arcs will be m divided by 2. Because it's always half of the sum of the degrees. Okay, now the next part of it. We've got 2 arcs there. So we've got 2 nodes. And the minimum span tree to connect these two would be just to connect them like that. So we've got 2 nodes, and we've got 1 arc. If we had a third node, then we're going to have 2 arcs. If we have a fourth node, we'd have to have an extra arc. So after our initial one, every additional node, you get 1 more arc. And so if you do this, you should see that the number of nodes is always going to be 1 more than the number of arcs. So if the number of nodes is n, the number of arcs is going to be n minus 1. And when you look at it like that, it's quite simple. Unless you're used to looking at it like that, though, it's a very, very tricky question indeed. And now finally, the last part, write down an inequality in terms of m and n, comparing the number of arcs in T and V. So we've got a connected graph. So if we consider this one over here as a connected graph, and that's got that many arcs and that many nodes, what we've got to do is we've got to compare the number of arcs in a connected graph and the number of arcs in a minimum spanning tree. Now, if we've got a connected graph, let's do it with 3 nodes. A connected graph, we've got 3 there. We cannot have that as a minimum spanning tree because it's made an arc. So the number of arcs in a connected graph is going to be m over 2. And that's got to be bigger than the number of arcs in minimum spanning tree, so that it doesn't make any loops like this one. So if we think about it with a different example, 1, 2, 3, 4. Let's say we've got this here. Here we've got 1, 2, 3, 4 arcs in our connected graph. So all of the 4 nodes are connected, and we've got 4 arcs to do that. However, if we were to take a minimum spanning tree, we could do that one, and that one. So therefore, the number of arcs in a minimum spanning tree, which is this one here, is going to be less than the number of arcs in a connected graph. There's only one time when that's not true, and that is in this sort of example here. So if we take a very, very simple graph, and we've got 3 nodes, or 3 vertices, and they're connected like that. If we're going to draw the minimum spanning tree for this here, so we've got A, B, and C, the minimum spanning tree is actually the same as the connected graph itself. So the connected graph is the minimum spanning tree. So in these occasions, the number of arcs in the connected graph is the same as the number of arcs in the minimum spanning tree. So therefore, we can say that it also equals that one. So that's what this question was on about, and it's only worth 1 mark, so it's not the end of the world if we don't get it. But this here represents the number of arcs in a connected graph. This here represents the number of arcs in a minimum spanning tree. Now the connected graph will always be bigger than the minimum spanning tree unless it is itself a minimum spanning tree. So that's what you had to do for the 3rd mark. And that, Year 12, is your video on D1. C1 to follow soon.